Welcome, this is our geometry review, chapter 10. Let's get to it. It says find the length of one base of a trapezoid if the other base measures 10 and the height is 8 and the area is 100. First step always is to write our formula out. Okay, so we can, instead of 1/2, I can divide by 2. And it tells me my height is 8, so we could do 8. Base 1 is 10. Plus base 2, we don't know the length of the other base, we can label that x, divided by 2, equals the area, which is 100. Okay, so this just becomes an algebraic problem. We multiply the 2 out, and that's going to give me 200 equals 8, and then 10 plus x. And then we're going to go ahead and get rid of the 8 by dividing by 8. And this is when you want to have your calculator out, so you can do this math quickly, because I do not know the math off the top of my head, even though I feel like I should have got that one. So 25 equals 10 plus x, subtract the 10, and we get x equals 15. Find the apothem, the area, and the perimeter of the hexagon. Leave your answer in radical form. Okay, well, first of all, the perimeter is going to be really easy. It's just going to be 10 times 6, so that's 60. So that's pretty simple. The apothem, we have to draw that little triangle and drop this down. And I like to also find the central angle. So we get 360 divided by 6. 360 divided by 6 is going to give me 60. And then half of that is 30, 60. So the triangle that we can take out of there, 60 down here, 30 right there. And what I'm going to do is I'm going to go ahead and figure out where the 10 is going to go. Since it's a side length, this is an apothem. It's going to cut this into 5 and 5, just like that. And once I know that we have the 5 and the 5, I can come in and I can label my rules. This is going to be x rad 3, this is going to be x, and this is going to be 2x. And if 5 is that piece that's half of the thing, we want to find the apothem, which is the yellow piece. So that's going to become 5 rad 3. So the apothem is 5 rad 3. And then to find the area, I'm going to do 1/2 a, the apothem, times the perimeter. So I do 1/2 of 5 rad 3 times 60. Okay, and half of 60 is 30. And 5 times 30 is going to give me 150. And I don't have any units here, so I'm going to do 150 rad 3 square units. And there's all 3 answers. Number 3, find the apothem, the area, and the perimeter of the equilateral triangle. Well, first off, the perimeter is going to be really easy. It's just 12 times 3, which is going to give me 36 for the perimeter. Next, I need to go ahead and draw this in. And we're going to find our central angle, which is 360 divided by 6. Just kidding, that's what I did on the last one. It's going to be 360 divided by 3 because we have 3 sides, which is 120. So on these triangles I get 120, 120. But half of that is 60, which is going to leave me with a 30, 60, 90 triangle. And I'm going to draw the triangle outside. And I know the perimeter already. This is going to break this into 6 and 6. So we get 6 down here. And I'm looking for my apothem, so I can solve using the formula. And this is going to be x rad 3, 2x, and x. Well, since this is in the x rad 3 position, I can divide by rad 3, which would leave me with this, and then rationalize, which would leave me with 6 rad 3 over 3, and 6 divided by 3 is going to give me 2 rad 3 for x. So I get 2 rad 3 as my apothem. And once I have both pieces, I can find the area And our perimeter is 36. Our apothem is 2 rad 3 and 1/2. Well, half of 2 is just 1, so we get rad 3 times 36, which is therefore my answer. 36 rad 3. No units here, so I'm just going to say square units. Find the area of a regular nonagon whose perimeter is 72. I gave you a lot less space than you would probably imagine, but we can fit this in. Our perimeter is given to us. I'm going to go ahead right off to the side of the perimeter. I need to find the apothem, which I don't know. And so what I'm going to do is I'm actually going to just draw the triangle, and I'm not going to draw the nonagon. But I'm still going to use 360 divided by 9, which should give me 40. But then this is going to be half of that because I cut it in half. I need to find the base length down here. Again, we have a nonagon. Let's just go ahead and try to draw it. I'm going to do so bad. 1, 2, 3, 4, 5, 6, 7, 8, 9. That wasn't too bad. And there we go. So we know in one of these it's 40. So I cut it in half, that's 20. And if I do 72 divided by 9, I'm going to get a side length of 8. So these are all 8 on the side lengths. So when I cut it in half, I'm actually going to get 4 as the side length. And I'm looking for the apothem, which is this small slice here. And so we're going to go ahead and see if we can solve for that using our trig. And we get opposite and adjacent. So we're going to do the tan of 20 equals opposite over the apothem. Since my unknown is in the bottom, I can switch the apothem with the tangent. And I'm going to get approximately 10.9 as the apothem. And so I just have to plug it into the formula. Area equals 1/2 apothem, which is 10.9, times 72. But remember, I keep the apothem answer in my calculator already. So all I'm going to do is multiply by 72, which is the perimeter, and then divide by 2, which is the last part. And we get the area equals 395.6 square centimeters. Okay, so a lot of work, not a lot of area. No pun intended. Find the area of a regular octagon whose side length is 16. So again, I can find my perimeter pretty easily, 16 times 8, and we're going to get 128. Okay, so I have my perimeter, so I need to find the apothem. So we're going to do 360 divided by 8, and I think that's 45, which is correct. But then we're going to get half of that when I pull the little triangle out. And so we get 22.5. Now 16 is the side length, so we're going to cut that in half. And I'm going to get 8 for the bottom and 8 for the other bottom. And we want to find the apothem. That's this segment right here. I've tried to be consistent using yellow as my apothem. And we are going to use our strategy for finding this, which is tangent. We have opposite over adjacent, so we're going to do the tan of 22.5 equals 8 over our apothem. Those two can switch spots, so the apothem is equal to 8 over tan 22.5, which means it's going to be approximately 19.3. So over here, our apothem is approximately 19.3, and we can plug that into our formula. 1/2 19.3 times 128. And again, I have the 19.3 in my calculator already, So all I really have to do is multiply it by 128 and then divide by 2. And then divide by 2. And we get 1236.07. I'll round that to 1236.1. And we are talking about centimeters again. Round to the nearest tenth, which we did. And there we are. Looks like this one was supposed to be rounded to the nearest hundred, so I was one off, sorry. All right, halfway done. Oh, yeah, about halfway, maybe a little over. Find the area of a trapezoid if its perimeter is 40 and the non-parallel sides are 9 and 5 and the height is 5. So first we'll just draw a little trapezoid. We know the non-parallel sides are 9 and 5, and we know the height is 5. So when I put in my formula, yeah, I guess I'll write it this way. That's okay. The height is going to be 5, but I don't know the bases. But since 9 and 5 is part of it, and I know the perimeter is 40, I could add 9 and 5 together, which would give me 14. And so I can take the perimeter and subtract 14 from it, and I'll get 26. So that means that the length of 26 should make up this segment plus this segment, which is base 1 plus base 2, which means I'm going to have 26 as my length of base 1 and base 2. Put that all together in our calculator, and we're going to get 5 times 26 divided by 2, which is going to give me the area equals 65 square feet. Okay? Let's look at our next problem. Find the area of a rhombus if one angle measures 60 and the small diagonal is 8 inches long. This is a tricky one because you got to pay attention to what it's saying. So you have a diagonal here and a diagonal here. We know they form 90s. Okay, so we're going to say the small diagonal is in blue here. Okay, so if that's 8, we're going to have to cut it in half to 4 and 4. All right, now it says one of the angle measures is 60. Okay, well, if that was true and this is 60 or this is 60, it's going to get cut in half. So no matter what, we're going to have this right triangle right here. It's going to have a 60 in half, which is 30. So 30's got to go somewhere, and 60 has to go somewhere else. Well, if I know 4 is here, okay, and it's the small side, so this is small, then would it make sense to put 30 here or 60? Well, if it's small, it should be opposite the smallest angle. And that means the other side should be opposite the bigger angle, which is 60. So that's kind of how you want to set that up. So the 30 would go here and here because it's opposite the small side. It just makes more sense. When we have 60 and 60 over here, that means this is 120. That should be opposite the bigger side. So you got to make sure you set that up right. Across from the 30 is x, and then this is going to be x rad 3. Which, since x is 4, we're going to get 4 rad 3. So we get one diagonal is going to be 8. The other diagonal is going to be 4 rad 3 plus 4 rad 3, which is going to be 8 rad 3. And then we're going to take half of that. So 8 times 8 is 64, divided by 2 is 32. So we're ending up with 32 rad 3 square inches. Okay. All right. Number 9. This is one where we have to find a height. We don't have a height. It's not a special right triangle. It's not. The overall is not a special right triangle that we know of. And so what we're going to do is we're going to use the area is equal to 1/2 base times height. Now that I have a height, I don't know it, but I have one. I'm going to use 20 as my base because it's perpendicular. Now, I gave you the angle measure of 45, which means I could technically use special right triangles. In this case, I'm going to, but I'm also going to show you how to use trig. Okay? So taking a look at this triangle right here, this side length is 8, and this is h. So this is actually in the x rad 2 position, which means to find h, it's just going to be divide by 2, multiplied by rad 2, so you get 4 rad 2. And so the height is 4 rad 2, and half of 4 is 2, 2 times 20 is 40 rad 2, and that's going to be square feet. Or let's do it using trig, our SOHCAHTOA. Using our eyes, we're going to get, instead of h, we're going to get opposite, and we're going to get hypotenuse. So we're going to use sine of 45 equals opposite is going to be h, I don't know it, over hypotenuse, which is going to be 8. Get the 8 out of there, we get 8 times sine 45. And that's going to be approximately 8 times sine 45. That's approximately 5.65. Now my calculator tells me, yo, that's 4 rad 2. I already knew that. But let's just say it's about 5.6. So the area could be 1/2. Still 20 is our base, but this time I'm going to get 5.6. That's already in my calculator, so I'm going to leave it in my calculator just like this. I'm going to multiply by 20, and my calculator knows it's a rad, so it's going to do that, but I get 113 divided by 2. Notice my calculator knows it's 40 rad 2, but we get the answer of 56.57 square feet. So those are two different ways you could do it. If you have a special right triangle, hint, hint, on the test, it probably won't be a special right triangle. So trig will be the way to go. All right, number 10 was an attempt to get a good, interesting question, and then it became kind of a messy question. So let's see if we can do it. In a parallelogram, a base and a corresponding height are in the ratio of 7:3. The area is 102. Find the lengths of the base and the corresponding height. We can do this. I don't know the base and I don't know the height, so I can give them the ratio of 7:3 by doing 7x to 3x. And then the area of a parallelogram is base times height. So we can plug those in, set it equal to 120. Well, this is going to become 21x squared equals 120. And then we're going to divide by 21. And if you're using your calculator, you're going to get about 5.7 equals x squared. Okay? And then we can take the square root of that number. And again, I have it right here. And then I'm going to do the square root of that number, the answer. Oops, one too many. And we're going to hit enter, and I get 2.39. So x equals about 2.39. Now, I can find the base by plugging x into it. So the base is going to be 7 times 2.39, which means it's about 16.7. So that's my base. And then I can find my height by doing 3 times 2.39, which is going to be So I got to set it up again. Sorry, my bad. One moment, I lost it in my calculator. Okay, that's going to be 7.17 about, and that's my height. Okay, and if you multiply those two numbers together, now those are rounded answers, but if I multiply 7.17 times 16.7, I get extremely close to 120. Again, these are rounded answers, so it's not perfect. Okay, but that's essentially how we could approach that problem. Last but not least, it says if the area of the smaller regular pentagon is 50, find the area of the larger. Okay, so this is where we're going to set up an area ratio and a scale factor. Okay, so the area ratio, we have small to large, and the small area is 50. I don't know the large. The small ratio is going to be 3 to 9. Well, that should reduce to 1 to 3, right? We can reduce that fraction, so we get 1 over 3. Now here's the problem. I can't set these equal to each other because this is a squared b squared, and this is a to b, which doesn't work out. So to make these the same, I could square these, and then it would be an equal statement, so I'm going to square these up here. Now we can cross multiply. We get x equals 3 squared times 50. Well, 3 squared is just 9 times 50, which is going to give us 450, and we're going to put meters on here, and I'm not sure why they didn't do square meters, but they should be because we're talking about area. All right, that is all she wrote. Hopefully that was useful. Good job. Good job. Good job.